Hello everyone, welcome to the lecture series on analog electronics. This lecture series comes under the Let's Crack the Gate initiative by TEQIP Faculties. In the last lecture, we saw how diodes work, and in this lecture, we'll see what diodes can do. So we'll do some problems, and through these problems, you'll get to know diode better. We have a problem, but before doing the problem, you need to remember something, and that something is we have a diode. The diode has an anode and a cathode. So the diode turns on when VAK, that is the anode to cathode voltage, is greater than 0, and people have already found some values for this. So if this voltage is greater than or equal to 0.7, then that is for silicon diodes, this VAK should be greater than or equal to 0.7 volts, and for germanium diodes, they should be greater than or equal to 0.2 volts. Actually, these values are not exact. For silicon, the value changes between 0.6 to 0.8, so we took the average, and for germanium, this value changes between 0.1 and 0.3, so we again took the average and decided this will be the case. Now, if you look at an ideal diode, we know that we don't have to go for any of this. If the diode voltage VAK is greater than or equal to 0, the diode is going to be turned on. In most of these problems, we are going to assume that the diodes are ideal. So let's do this problem, see what we can infer from this. So in this problem, it is asked to determine the biasing of the diode shown in the figure. Now to do this, in this problem I will explain one method, and in the next problem I will explain another method, and then you can decide which will suit you better. Alright, so we have a diode, a resistor, and the end of this circuit is, two ends of this circuit is connected to two voltage levels. One is plus 3 volt and another voltage level is plus 7 volt. So in questions like this, what you have to do is, we will assume that the diode is reverse biased. So we are making an assumption. After making the assumption, we will check whether our assumption is right. If our assumption is right, then we know the biasing of the diode. If our assumption is wrong, then also we know the biasing of our diode. So let's see, if we assume this diode is reverse biased, then we know that a reverse biased diode will act as an open circuit. So we will redraw this figure. Now our diode is a open circuit. Now our diode is open circuited. So here we have plus 3 volt, here we have plus 7 volt. This is the anode of our diode and this is the cathode of our diode. Now we will see what is the anode voltage. Now we know that there is no current flowing in the circuit because this is open circuited. So anode voltage will be plus 3 volt and cathode voltage will be plus 7 volt. Right. So what will be VAK, anode to cathode voltage? That will be VA minus VK, which will be equal to 3 minus 7, right? That is minus 4 volt. What can we infer from this? Our VAK is less than 0, so the diode must be reverse biased. So that means our assumption was right and the diode is reverse biased. Now for the next problem, now we have another diode here in another circuit. For this circuit as well, we will use open circuit criteria, open circuit test, and let's redraw the figure. Let me first phrase the question. We have to determine the biasing of the diodes shown in the figure. Here again we have a resistance and a diode in series connection, and the end terminals of this circuits are connected to minus 10 volt and minus 18 volt. Now you have to find the biasing of the diode. Now you know how to find the biasing of the diode. We have one method to solve this problem. So pause here, take your time and find out the result. After that, start the video and see if your answer is right or not. Okay. Now again, we will make the assumption that our diode is reverse biased. So diode will act as an open circuit. So here we have minus 10 volt, resistance 1 kilo ohm. We have minus 18 volt. This is our diode's anode and this is our diode's cathode. Now what will be VA? VA will be minus 10 volt. VK will be minus 18 volt and VAK will be VA minus VK, which will be minus 10 minus 18, that is 8 volts. So if VAK is 8 volts, what does that mean? VK is 8 volt, that means VAK is greater than 0 and our diode is forward biased. Right? I hope this is clear for you. Then we can go for the next problem. Here we have two diodes, and again we have to determine the biasing of the diodes. On the figure, there is diode D1, diode D2, and the connections are like this. Here we have plus 10 volt, at the bottom we have minus 10 volt, and there are two resistors, 10 kilo ohm and 5 kilo ohm. In this case, we will apply our second test, and the second test is short circuit test. So in short circuit test, we are assuming that our diodes are forward biased. So forward biased ideal diodes will act as short circuit. So we'll assume our diodes are forward biased, hence they are short circuited. Okay, so let's see what happens. Now this is short circuited. We have our diode, this short circuited, resistance. Here we have minus 10 volt, here we have plus 10 volt, and here we have our ground, right? But when we are making this assumption that these diodes are forward biased or short circuits, we have to keep in our mind that the current direction should not change. For a forward biased diode, the current flows from anode to cathode. So the current direction in D2 must be in this direction, and the current direction in D1 must be in this direction. Let's denote those currents, I1 and I2. So according to our assumption, current I2 must flow in this direction and current I1 must flow in this direction. We'll check that. Now this diode is short circuited, so this point is directly connected to this ground. So we can find out the value of I1. So we'll get I1 as 10 minus 0 divided by the resistance, which is 10 kilo ohm. 10 kilo ohm, that is 1 milliampere. And the direction of current is not changing. So direction of current is what we had assumed. The current is flowing in this direction only. Now there is a current I in, let's assume there is a current I in this direction, current flowing in this direction. That I is given by, here the potential is 0 volt, that is 0 minus 10 divided by the resistance, which is 5 kilo ohm. 5 kilo ohm. How much will it be? 10 divided by 5 kilo ohm, that will be 2 milliampere. So a current of 1 milliampere flows in this direction, a current of 2 milliampere flows in this direction. That means I2 must be what? 1 milliampere. We know this by KCL. So I2 must be 1 milliampere. So 1 milliampere flows through here, 1 milliampere flows through here, they get added, and 2 milliampere flows here. What does it mean? We had assumed that these diodes are forward biased, hence they are short circuited, and we have also denoted the direction of current flow if they were forward biased, and we have seen that our assumption is right. The current flow direction is not reversed, so our diodes must be forward biased. So this means that both D1 and D2 must be forward biased. So in this case, D1 and D2 are forward biased. Okay. So we have seen two methods. First method is open circuit test. In open circuit test, we will assume that the diode is reverse biased, and then we will check the voltages at the anode and cathode terminals of the diode. If our assumption is right, we will find the, if anode voltage is more positive than cathode voltage, or VAK is greater than 0, then we know that the diode is forward biased, right? If the diode is forward biased, then our assumption is wrong, but we have a method to find the biasing of the diode. In the second case, we are assuming that our diodes are forward biased. In forward bias, we know that the diode will act as a short circuit, and we also know that the current direction is from anode to cathode. So we will assume the current directions, and then we will solve for the current direction, and we will see that if the current direction is as we assumed, and if it is as we assumed, the diodes are forward biased. If the actual current direction, that is the circuit current direction, is reversed, that means the diodes are reverse biased. Okay. Now we have another circuit here. In this circuit, what we have to do is we have to find the value of current I shown in the circuit. This is the current I, and we have to find this value of I. Again, this is up to you. We will, as I said in this problem also, we will assume that the diodes are ideal, then we will find the value of I, and most of the time it will be given in the question. Okay. So to find out I, we can do both our tests. We can either do for short circuit test or open circuit test, and then we can find out the biasing of the diode. After finding out the biasing of the diode, we can find out the value of current. So for this problem, I will go for short circuit test because we have done two open circuit tests. Now we have only done one short circuit test. Let's go for short circuit test. So let's redraw this figure. Okay, this is our circuit. This is 5 volt, 1 kilo ohm, and this diode D1's current direction must be this direction. This is again 1 kilo ohm. Diode D2's current direction must be in this direction, calling it I1, and this is I2. Okay, and this is 8 volts. Now we have two meshes, and let's call this current IA, and let's call this current IB. Now we can find out the values of IA and IB, and then we can find out the values of I1 and I2, and after finding out the values of I1 and I2, we'll know that whether the diodes are forward biased or reverse biased. Now let's find out the values of IA. So in the first circuit, you can see that IA will be equal to 5 divided by 1 kilo ohm, and that is 5 milliampere, right? In the second circuit, we can find IB as IB is equal to the value of IB 8 volt divided by 1 kilo ohm, that is 8 milliamps. So we have found the value of IA as 5 milliampere and IB as 8 milliampere. Now we can find out the value of I1 and I2. What will be I1? From the figure, I1 will be IA minus IB, right? By looking at the direction, we can see that I1 will be IA minus IB. So IA is 5 milliampere, IB is 8 milliampere. So I1 will be 5 minus 8 milliamps, that is minus 3 milliamps. And I2 will be equal to, what will be I2? Same as IB. So I2 is same as IB, that is 8 milliampere. If you look at the circuit, we have found a direction for I1, that is this direction by our assumptions, but the value of I1 is negative. It is minus 3 milliampere. What does it mean? It means that the actual direction of I1 is this. So when we look at the circuit, this current direction implies that the current is flowing from cathode to anode. That cannot happen under forward bias. That means our diode D1 is reverse biased and diode D2 is forward biased. Let me denote it here. So diode D1 is reverse biased, RB means reverse biased, and diode D2 is forward biased, that is FB. If diode D1 is reverse biased, it means that it is an open circuit. If diode D1 is open circuit, what will be the value of I? I will be equal to 0. The value of current I in this circuit is 0. Okay. Now let's move into the next question. Assume that the diodes are ideal. Find out the value of V0. Now pause it here. Try to find out the value of VO. And if you get the value, very good. If you didn't, just start the video again and we'll see how to do it. Again, 2 for open circuit, 2 for short circuit, go for open circuit. So I'll redraw this circuit. This is open, 10 volt. There are 2 resistors connected here, 1 resistor here. Again, open circuit connected to 15 volt. Here we have V out. So this is 10 kilo ohm. This is again 10 kilo ohm. This is 10 volt. This is the anode of D1. This is the cathode of D1. This is 10 kilo ohm. This is the anode of D2 and this is the cathode of D2. In open circuit, we just have to look for the voltage levels of anode and cathode. Now, when we look at the anode and cathodes of D1, you can see that the anode is connected to plus 10 volt. This point is connected to ground potential. So anode is connected to plus 10 volt and cathode is connected to ground voltage. What does that mean? This VAK is greater than 0, right? Anode is connected to plus 10 volt and cathode is connected to ground potential. That means that this VAK is greater than 0, right? If we look at this case, this is 15 volt, cathode is connected to ground, there is no current flow, then we don't have to bother about the resistances, right? Cathode is connected to ground and anode is connected to minus 15 volt. So what will be VAK? VAK will be less than 0, right? If we write those values, for D1, VAK1 will be equal to plus 10 volt, and for D2, VAK2 will be equal to minus 15 volt. What does that tell us? It tells us that diode D1 is forward biased and diode D2 is reverse biased, right? So in that case, the entire right part of the circuit is open, so we don't have to bother about it. And this on the left part, diode D1 is forward biased and it is short circuited. Let me redraw the circuit. The circuit became like this. Now here we have our P out. This is kilo ohm, this is kilo ohm, this is 10 volt. Now you know the answer, right? Voltage connected to two series resistance, both are equal resistances, so this voltage will be equally distributed across this resistance. What will be the value of V out? V out will be 5 volt. Okay, clear? Now next question. The IV characteristics of a diode is given by I equal to V minus 0.7 divided by 500 when V is greater than 0.7 and 0 otherwise. Find out the current in the circuit. So we have a circuit, a 10 volt connected in series with 1 kilo ohm resistance and a diode, right? And the current characteristics of this diode is given by V minus 0.7 divided by 500. So from this characteristic we can say that this is a silicon diode because there is a current when voltage means voltage across the diode. Voltage across the diode is greater than 0.7 and when it is less than 0.7 the current is 0. This is a silicon diode, right? So we have the characteristic equation for the diode is I equal to V minus 0.7 divided by 500. So let's say that the diode is forward biased, that is V is greater than 0.7. Let's try to draw the equivalent circuit of this diode, right? So we know that this is a practical diode because we are given with a voltage condition and resistance condition. So if we redraw this equivalent circuit, we know that there is a voltage constraint, that is the diode will be on only after the voltage across the diode becomes greater than 0.7 and the voltage and current relation, there is a constant determining that relation and that constant is given by the number 500. So that constant must be a resistance value 500 ohms and then there will be an ideal diode. Across this we have the voltage V. When we apply V here, there is a flow of current I and this I is given by V minus 0.7 divided by 500 and to show that this happens only after V greater than 0.7 we have a diode here, right? Let me redraw V. The voltage across the diode will be V, right? Voltage across this point will be V and the current I is given by V minus 0.7 divided by 500 because when V is greater than 0.7 this diode will be forward biased and it will act as a short circuit. Then you can find out the value of I in this circuit by applying KVL, right? Okay, let's redraw this circuit on the left by applying this equivalent circuit at the diode side. So we have our 10 volts and a resistance of 1 kilo ohm and the diode is now changed to the equivalent circuit. This is 0.7 volt. This is 500 ohm. This is our ideal diode. Now again we can assume that this diode is forward biased, and there is a current I flowing in this. So this ideal diode is now forward biased, and a current I is flowing in this direction, and now we can find out the value of I. If the value of I that we find out is positive, that means the diode is forward biased. So our assumption is right, and we also get the value of I. Two birds with one stone. Let's see that. So the I in this case will be given by KVL. So supply KVL, and we get I as 10 minus 0.7 divided by, in case 1000 plus 500. That will be 9.3 divided by 500. That current is 6.2 milliampere. This is a positive current. So diode is forward biased. There is no doubt in that. And also got the value of the current that was asked in the question. Okay. Now, the last problem in this lecture, we have two diodes, D1 and D2. We have to assume that these diodes are ideal, and we have to find the value of I. This is I. Okay. This circuit is supplied by a current source of 1 milliampere current. There are two resistance, 2 kilo ohm and 2 kilo ohm. Again, in the last case, we assumed that the diode was short circuit. This case, we will assume that the diode is open circuit. Let's redraw the circuit, and before going into the solution, pause it here and try to solve it by yourself. Okay, let's see. These are two resistances. I'm going to assume that these two diodes are open circuit. This is diode D1 and this is diode D2. And this is the anode of D1, this is the cathode of D1, this is the anode of D2, and this is the cathode of D2. There is 1 milliampere current flowing through this. Now, we know that these two are open circuit, so current will flow in this direction through these two resistances. So here we have 2 kilo ohm, and here we have another 2 kilo ohm. When 1 milliampere current flows through this 2 kilo ohm, there will be a voltage generated across this, and that voltage will be 1 milliampere into 2 kilo ohm. That will be 2 volts. Again, the current direction is this. Current is flowing in this direction, and it is flowing through this 2 kilo ohm. Again, there is a voltage drop in this 2 kilo ohm resistance, and that will give a, there is a voltage drop in this 2 kilo ohm resistance, and that will also be 2 volts. Now, when we look at the diode D1, its anode is connected to plus 2 volt, and its cathode is connected to the midpoint. So VAK1 will be plus 2 volt. Now, what about VAK2? Anode is connected to minus 2 volt, cathode is connected to this reference potential. So VAK2 will be minus 2 volt. That means that diode D1 is forward biased and diode D2 is reverse biased. If diode D2 is reverse biased, no current can flow through it, and the value of I will be equal to. Okay. Now you know how we can find out the biasing of diodes, right? And you can use this information, that is, you can use these two tests to identify the biasing of diodes. If you think you have learned something new, or if you have relearned something you already knew, please subscribe to our channel. With that, I conclude this lecture. We'll see in the next part. Till then, bye.